before we get started? Question on any of the assignments? No cheat. Questions on the homework? What we're starting today is addition and subtraction, adding or subtracting rational expressions. Now, to be able to add or subtract rational expressions, the denominators have to be the same. They have to be the exact same. So if I had 3/4 plus 7/4, the denominators are the same, so we can add the numerators. Well, 3 plus 7 is 10. We had 10 over 4. Now, we do need to make sure that if it can reduce, we reduce it. So 10 over 4 reduces to 5/2. If the denominators are the same, we can add or subtract the numerators. So if we look at the first one, 7 over 4x plus 3 over 4x. Since they're both over 4x, we can add the numerators. So we'd be adding the 7 and the 3. Well, our 7 plus 3 gives us 10 over 4x. So the 10 over 4 reduces to 5 over 2. And we still have our x in the denominator. But 7 over 4x plus 3 over 4x gives us 5 over 2x. Questions on this here? Let's look at the next one. 2x over x plus 6 minus 5 over x plus 6. Since the denominators are the same, and so just say x plus 6, we can subtract the numerators. It's 2x and 5 like terms. So this was it. Now we would make sure that the numerator, not denominator, but the numerator, 2x and 5 don't have the greatest common factor. We can pull out, there's no way to factor it at all. So that is as far as that one goes. Questions on this here? Let's look at the next one. 8 over 12x minus 5 over 12x. Now it might be very tempting to want to simplify our 8 over 12x. Because if we did, they do have a common factor of 4, which would be 2 over 3x. But if we do this, the denominators are not the same anymore. So there's no point in simplifying the 8 over 12x. Because for us to be able to add or subtract, the denominators have to be the same. So it'd be 12x. And we can subtract our numerators. Now 8 minus 5 is, so we'd have 3 over 12x. Will this reduce? We still have the x. The numerator would become 1. The denominator would be what? What's in common with 3 and 12? 3. So, because 3/12 is the same as 1/4. So we'd have 1 over 4x. Let's look at the next one. 2 over 3x squared plus 1 over 3x squared. Denominators are the same, so we can add the numerators. Almost. Because our 2 plus 1 would give us 3, which would mean we have 3 over 3x squared. 3 over 3 would reduce to 1, but over x squared. If the x squared had been in the numerator, yes, it would have reduced just to x squared. But because the x squared is in the denominator, it reduces to 1 over x squared. Questions on this here? Let's look at the next two. 4x over x minus 2 minus x over x minus 2. Since the denominators are the same, we can subtract the numerators. Now our 4x minus x gives us it would be 3x, because 4x minus x, you're good, 4x minus x is 3x over x minus 2. 3x can't be factored any farther, x minus 2 can't be factored any farther, and since there's nothing in common, that is our final answer. Maybe doing it for a while. Number 4, 2x squared over x squared plus 1 plus 2 over x squared plus 1. Since the denominators are the same, we can add our numerators. They're not like terms, but there is something in common with both. What is in common with both our numerators? The constant is, so we can factor out a 2. Because if there's a greatest common factor, we do need to factor it out just in case there is something in common. Because if we factor the 2 out of x squared, we're left with x squared. If I factor 2 out of 2, we have 1. Is there something in common on top and bottom? X squared plus 1. So those would cancel, leaving us with 2. Questions on any of those so far? Now, as a side note, we've talked about restrictions, like the one before this, x minus 2 in the denominator. Because our restriction is that we can't have a value of x that would make x minus 2 be 0. And if we solve this, well, we would say x cannot be 2, because if we have 2, 2 minus 2 is 0, we have a division of 0. And we've seen that with several problems so far. What I want to look at before we move on is the denominator here, x squared plus 1. Because again, we can't have any value of x that would make this be 0. So we can solve this here. So the first thing we would do is subtract 1, telling us x squared is equal to negative 1. And at this point here, we would square root both sides. Our square root in x squared would be x is equal to plus or minus. Well, what is the square root of negative 1? There is. It's 1i, or just I. So the value of x that would make x squared plus 1 be 0 is positive or negative I, yes? Is I or negative I a real number? No. So is there any value of x that would make x squared plus 1 be 0? No. So there are no restrictions for this one, because there's no way to make a division of 0. So some of them won't have a restriction. Some will. Questions on any of this so far? Now, not every rational expression will have like denominators. So if they aren't the same, we have to make them be the same. And in order to make two rational expressions be the same, we have to find the least common multiple, or least common denominator. The smallest term that will make them both be the same, the first thing we can turn both of them into. Now we can do an example of this here. Let's say 3/8 plus 4/15. Because if we want to add these together, we need the denominators to be the same. Now to do that, we need to find the least common multiple. Well, really it's going to be least common denominator for fractions, but they're more or less the same expression. And to do that, we're going to do prime factorization, our factor trees. Because 8 will be 2 times 4. And 4 is 2 times 2. So this is our prime factorization. So 8 is 2 to the third. 15 is 3 times 5. And that's as far as that goes, because those are all prime factors. And when we look at the least common multiple, we take whichever one has the most of each term. Since 8 has 2 to the third, that's the most of it. And 15 has 3 and 5. So we end up multiplying these together, and it ends up being just 8 times 15, which is 120. Because 120 is the first number that we can turn both 8 and 15 into. So to get these to be the same, well, 15, 3 times 5, we're missing that 8. 8, we have to multiply by 15. Because on the left-hand side, 8 times 15 is 120. 15 times 8 is 120. Now our numerators, 15 times 3 is 45. 8 times 4 is 32. Now 45 over 120 is still 3/8. 32 over 120 is still 4/15. But since the denominators are now the same, we can add the two together. Well, 45 plus 32 is 77. If there's a common factor on top and bottom, we would reduce. How would we add 2/3 and 4/5?
Add 2 plus 4 plus 5. Oh, we wouldn't, because that has to be the same.
We have to have the denominators be the same. What would we need to turn them into to make them be the same?
If you take the lowest prime number,
Okay, which is?
oh, this is different. 1 and, no, it's 3 and 5.
3 and 5.
Yeah, 3 and 5, but.
So our least common multiple would be? Because the first number we can turn 3 and 5 into is 15. Now, if we look at the prime factorization of 3 and 5, well, it's just 3 and 5. So we need to multiply the 5 by 3 and the 3 by 5. Because if we do this, 5 times 3 is 15. 5 times 3 is? But since we do multiplying the bottom by it, we also have to multiply the numerator. Because 5 over 5 and 3 over 3 is just a fancy version of 1. Anything divided by itself is 1. 5 times 2 is 10. 4 times 3 is? Because 10 over 15, 12 over 15 is still 2/3 and 4/5 respectively. 10 plus 12 is? Is there a common factor between 22 and 15? No. So it's simplified. And again, finding this least common multiple is going to make it a lot easier to solve these.
I wonder why that one was so much easier. I don't know where you got the 2/3 on the first problem. That's what threw me off.
Yeah, I think that's.
Well, that was.
Dang, I feel really dumb. Yeah, where did you get the 2/3 from? That's.
It's from the tree. See? Yeah, but. See, there's 3 too. And it's 2/3.
That's too cute. That's too cute.
Yes.
But the 2/3, what?
Where? Okay.
2 times 2
Times 2.
4.
Okay.
times 2.
Oh, okay.
8.
Jessica, you were
Just-
confused so long ago.
Yeah, what did you say? Well,
You were just confused in conversation.
no, I got the other part. You said 12 right after, or right, yeah, right after that.
Yeah, because I did mine to 0.
We're caught up now.
We're caught up now,
Finally.
guys.
Jessica, you were.
You were literally just confused.
Now, again, making the least common multiple, finding this is key for solving this here. Because what we could have, because we could also use 6 and 10 to solve this here. Because if we do this here, what's 5 times 6?
Or I mean, 30, sorry.
30. 10 times 3 is 30. So the denominators are the same. 10 times 2 is 20. 4 times 6 is. So these are still the same multiples. 20 plus 24 is
44, sorry.
44. Is there a greatest common factor between 44 and 30? I mean 2, yes? If I take 2 out of 44, we have 22. 2 out of 30 is. Isn't that what we had to start with? But this time we use 30 instead of 15. That's an additional factor of 2, because we multiplied 15 by 2 to get 30, yes? But what did we have to remove at the last step? An additional factor of 2. Any factor we go over the least common multiple is going to come back out in the end. Because if we add another one in, we have to pull it back out. Because I added, because the least common multiple for this here is 15. I used 30, which gave another factor of 2 I didn't need. It still gave us an answer, but I had to remove that extra factor. Anything over this least common multiple will have to be reduced back out. So, before we get into expressions, we're going to work on a few problems with finding least common multiple. Okay. Now the best way to do this is factor tree. And we're going to use prime numbers. Well, the smallest prime number is not 1. It's actually, what? 2. Because 8 is 3 times 4. 4 is 2 and 2, which is all prime numbers. So the prime factorization for 8 is 2 to the third. 14 is 3 times 7. And that's actually as simplified as it gets. And 16, 2 times 8. 8 is 3 times 4, and 4 is 2 to the 4th. Least common multiple. When we look at all the terms for our least common multiple, we take whichever factor has the most or shows up the most in each one. Out of all the 3 of these here, we can start with 2. Well, 14 has 2 to the first, or 1, 2, yes? 8 has 3 of them, 2 to the third. And 16 has 2 to the, which one has the most? So we need 4 2s, or 2 to the 4th. Because again, we're trying to find the first number, or first set of terms that all 3 of these will be the same. First spot where they're all going to be the same. Well, the only other term we have is to the first, so we include it. Because again, we're trying to find the first number that I can turn 8, 14, and 16 into. Well, at this point, if we want to find out what that number is, I can grab the calculator and say 2 to the 4th times 7, which is 112. So the least common multiple of 8, 14, and 16 is 112. That is the first number we can turn all 3 of these into. Question on this here. Now, if we want to see what we need to multiply each one of these by to get there, we can really use, oh, if I can pick my color, this here. So we need 4 2s and 1 7. 8 has 3 2s, so it's missing, and it's missing a 2 and a 7. If we look at 14, it has the 7 and 1 2, it's missing 3 2s, so we can multiply it by 2 to the third. 16, well, we have all of our 2s, we're just missing a. So it tells us the first, or what it actually needs to be the same, and it also helps us see what we need to multiply the others by to get there. Does that make sense? Because this is helpful, especially for adding or subtracting fractions and getting the denominators to be the same. And we're starting with numbers because that is a point.
Wait, so what was the answer?
112.
4 times 7 equals 12?
Because the least common multiple is 112. Its setup is 2 to the 4th times 7. Now the next one we're going to look at is 9, 12, 15. Well, 9 is 3 times 3, and we could rewrite this as 3 squared. 12, 2 times 6, and 6 is 2 times 3. Which, if we wrote this as the prime factorization, would be 2 squared times 3. And 15 is 3 and 5. We can start with 2's first. Well, the only number that actually has 2 is 12, and it has 2 of them, 2 squared. 3's show up everywhere. 15 has 1 3, 12 has 1 3, and 9 has 2. So how many do we need? 2. Well, and then we need 1 5. So 2 squared times 3 squared times 5 is our least common multiple. If we want to find out what that is, 2 squared times 5 is 180. So the least common multiple is 180. Questions?
So how do you get 3 squared and 5? I don't understand.
Which number has the most of each term? 2's. 12 has the most 2's, yes? So we take both. Which one has the most 3's? So we take both of those. We don't need the 3 from 5, 15, or 12 because it only has 1. 12 has, or 9 has 2. Which one has the most 5's? 15. We take however many that is.
So what way do we need to get to 6 and 12?
Because 6 is not a prime factor. Because 2 times 3 is.
Oh, so they have to be prime factors on the least common multiple.
Because least common multiple, 9, 18, 27, 36, 45, 4, 190, 108, no, it's not 116.
Oh, thanks. So what?
Factors of 9. 84.
Not even a pickle.
84. 6. 108. 132. 146. Yeah.
No, stay.
132. Doesn't make any sense.
We need to get the most spicy one. Well, it's not even spicy. Okay, you're right. Who's with Allie? Who's with Allie this year and Julie's nine?
Ah, that's why. Four, 156, 168. All right, guys, 15.
Where's that one time? I'm in heaven now.
That's great.
I'm so happy here.
So, guys, if we look at the factors of 9, 12, and 15, because if we look at just 9 and or 15 and 12, because going through 12, 15, 60 is the first number we can turn 12 and 15 into, but 60 does not show up for 9. It's not a factor, so that is not the first number we can turn all three into. If we keep going, 120 is in common with both of these here, but 9. 120 is not a multiple of 9. And we could keep going out farther, and the next one that comes up is 180. 180 is the first number we can turn all three of these into. So the least common multiple for 9, 12, and 15 is 180. So we can either write out all the multiples or do this here. And we get the same answer.
That makes a lot.
Now, if we want to turn them all into this, well, the prime factorization for our least common multiple is 2 squared times 3 squared times 5. Well, 9 has the 3 squared. It's missing the 5 and the 2 squared, because if we add that to it, we would get 180. 12 has the 2 squared, but it's missing a factor of 3 and a factor of 5, because if we multiply it by the 3 and 5, we'd get our 180. 15 has the 5, but it's missing the 2 squared and 3.
All right.
Now, all right, we're going to find the least common multiple between 4x squared minus 16 and 6x squared minus 24x plus 24. And with both of these here, we need to factor it out completely, or factor them down completely. 4x squared and 16. What can we do first?
2x plus and minus 4.
Yes, but is there a greatest common factor?
Oh, 4.
4. So we can factor the 4 out. Because if we factor the 4 out, we're left with x squared minus 4. Our x squared minus 4 is a difference of perfect squares, which would be x plus 2 and x minus 2.
Oh. I'm just kidding. I'm just kidding. Seriously.
So that is factored. 4 times x plus 2 times x minus 2 is the factored form. If we look at our next one, is there a greatest common factor between these three terms here? 6. And if we factor it out, we'll have x squared minus 4x plus 4. Since our third term is positive, our signs are the same and match the sign of the middle term. Both would be negative. Factors of our x squared would be x and x. And the factors of 4 we want are 2 and 2. So least common multiple, we want to find the first expression that will make both of these be the same. So the first thing we can look at is 4 and 6. We can do the prime factorization. Well, 4 is 2 and 2, or we can say it is 2 squared. 6. Well, that is, and that's its prime factorization. Now, when we look at both of these here, 6 has 1, 2. 4 has 2. So how many do we need? 2. 2 squared. Because since 4 has 2, we need both of them. Then we also need a 3. So our prime factorization, well, not prime factorization, but our least common multiple for 4 and 6 is 2 squared times 3, which is 12. Because the first number we can turn both 4 and 6 into is 12. Questions on this here before we start looking at our other expressions? So let's start with x plus 2. Our expression on the left has 1x plus 2. How many x plus 2's do we have in the other? 0. So we need 1 x plus 2, because since it was listed in 1, it will be a part of our least common multiple. Questions on this so far? Now the one on the left also has 1x minus 2. The one on the right has 2. So how many x minus 2's do we need? Because we can say x minus 2 times x minus 2, or indeed, we could list this as 12 times x plus 2 times x minus 2 squared. But that's the least common multiple. Now, if we did want to turn both of these into the same expression, the one on the left, we do need to multiply the 4 by 3 to give us our 12. And it also needs one more x minus 2. The one on the right, to turn 6 into 12, we need to multiply it by 2. And it's also missing in x plus 2. Because it has the x minus 2 squared, we have 2 of them. It's just missing the x plus 2.
So 2 times 12. Oh, I get it. Dang.
Because if these are the denominators, the bottoms of the fractions, they are now the same, and we can actually add and subtract. Let's look at the next one. Let's look at this one here. 6x squared minus 54 is our greatest common factor. So we can factor it out, leaving us with x squared minus 9. X squared minus 9 is nice because it's a difference of perfect squares. So in factor 2, x, almost, 3. X plus 3 and x minus 3. So that there would be our least common multiple. 9x squared minus 54x plus 81. Those three have a greatest common factor of 9. So we'd have x squared minus 6x plus 9. Since the third term is positive, our signs are the same and match the sign of the middle term. So we have negative, and factors of x squared would be x and x. And the factors of 9 that we want are 3 and 3. Least common multiple. So the first thing we need to find the least common multiple of is 6 and 9. Does anybody have a guess at what the first number we can turn both 6 and 9 in? Who is? So least common multiple will always be bigger than both numbers. 18. Because 6, if we did the prime factorization, would be 2 times 3. 9 would be 3 times 3. So we need at least 1 2, 2 3s. Well, 3 squared is 9, and 9 times 2 is 18. Now, if we look at our sets of parentheses, the one on the left has 1x plus 1, or not x plus 1, x plus 3. The one on the right has none, so we need 1 x plus 3. The one on the left has a single x minus 3. The one on the right has 2. X minus 3 squared, yes. So to make them be the same, well, the one on the left, we need to multiply the 6 by 3, and we're missing an x minus 3. The one on the right, we have to multiply the 9 by 2, and we also need to multiply it by x plus 3, so that they would be the same. Questions on this here? Are you ready for the next one? We want to find the least common multiple between 5x cubed and 10x squared minus 15. Five x cubed is a single term, so it is simplified. 10x squared minus 15x. Is there a greatest common factor between these two terms? So 5, yes. Anything else? 5x. If we factor a 5x out of 10x squared, we're left with 2x. 5x out of 15x would be 3. Now, if we look at each term, so we'll look at 5 first. 5 is already prime, and they both have 1 5. So we need a single 5. Let's look at x. One of them is x to the third, the other is x to the first. How many x's do we need? We need x to the third, we need 3 of them. Well, that takes care of the entire left side, yes? Everything's accounted for? On the right, we do have this, but we also have, because one of the terms is 5x cubed. One of them has x to the third. So both of them need to be x to the third. Yeah, because we need them to be the same. Because this one here is missing 2, because if we want this one to be the same as this one over here, we do need to multiply it by x squared, which would give us a 5x cubed for both. But the one on the left is missing a 2x minus 3. So the least common multiple for these two here is 5x cubed times 2x minus 3. Questions on this here?